when we have a squared. Do you remember I told you to do whenever you have a squared? Like in completing the square, and in vertex form? Yes. When it was in vertex form and I asked you to put it into standard form, you guys always wrote it out twice, correct? And then you FOILed it? Well, here's the time again. Okay. So I just crossed the 2 out, and I rewrite it again. 4 root 3 plus 3 root 5. And yes, the marker showing is back again. I'm going to have to restart it. That just happened today. Restart it. Hopefully it doesn't tomorrow. All right. So we have to still do first times first. So 4 times 4 is 16. And root 3 times root 3 is 3 in brackets. Then we do outside. 4 root 3 times 3 root 5. 4 times 3 is 12. Root 3 times root 5 is root 15. And inside, 3 root 5 times 4 root 3. 3 times 4 is 12. Root 3 times root 5 is root 15. Now your middle terms are going to end up being the same whenever you end up foiling the exact same two factors, right? And then last times last. So 3 times 3 is 9. And then root 5 times root 5 is 5 in brackets. 16 times 3 is 48. Plus 12 root 15 and 12 root 15 is? Yep. Plus 45. And then we can go 48 plus 45, which is 93. 24 root 15. We don't need any restrictions because there's no variables under the denominator. We're going to look at C. Immediately before I even go to FOIL this one, I have a square root x under my denominator. What do I have to do when I have a square root x? I have to say x has to be greater than or equal to what? 0. It can't be negative under there. And then I'll be able to FOIL. First times first. What's root x times root x? X. Do you see I have an equal sign? Because this equals this equals this. There's going to be equal sign running down the left-hand side. So root x times root x is x, or x in brackets, but there's nothing else with it, so I'm just going to put an x. Root x times negative 3 is negative 3 root x. 1 times root x is positive 1 root x. And then 1 times negative 3 is negative 3. Now, can we collect any of these? Do any of these go together? It's a root x and that's a root x, isn't it? So I can put those together. What's negative 3 root x plus 1 root x? Negative 2 root x plus x minus 3. Those aren't like terms. There's nothing I can do with them. And then behind I go x has to be greater than or equal to 0. That's where I'll always write my restriction with a semicolon at the end. So you guys are going to try the try and D in the other try. So try these 3. So the first one, when we go to FOIL it, we get x times x, which is equal sign. Make sure you have equal signs running down your left-hand side. If you don't, put equal signs. X times x is x squared. X times root 5 is x root 5. X times negative root 5 is negative x root 5. And then root 5 times root 5 is 5. So we have x squared. Now, if we have x root 1x root 5 minus 1x root 5, what actually happens to them? They cancel. Do you see the middle terms cancel off? This is leading you to something for today, so let's pay attention. Those two look exactly the same, but what's different between the two?
Signs.
The signs. Oh, she didn't see that being right. Good job. All right, so the signs are different, but everything else is the same. We agree? They're called conjugates. When you have two things that look exactly the same, opposite signs, they're called conjugates. And what conjugates do is they actually make the middle terms cancel. Do you see how these two cancel? When you multiply by a conjugate, the middle terms cancel. They'll always be positive the same thing, negative the same thing, then they'll cancel off. Plus 5. Done. What's this one? Oh, it's not a conjugate. Why isn't this one a conjugate? Opposite signs. That's square roots. This is a 2, that one is a 1. They're really nothing alike. Okay, 2 root x times root x is 2, and then x in brackets. 2 times 2 is 4 root x. Minus 1 times root x is minus 1 root x. Minus 1 times 2 is negative 2. So we're going to get 2x. 4 root x minus 1 root x is 3 root x minus 2. Are any of these like terms? This one has x, this one has root x, this one has nothing. No. The second try, what do I have to do? Write up twice. So I'm going to get 2 root x plus 1. Are these conjugates? They look exactly the same. Does that mean they're conjugates? No, conjugates look exactly the same, but opposite sign in the middle. So the middle terms aren't going to cancel here, right? They're actually going to double. So we go 2 root x times 2 root x. 2 times 2 is 4. Root x times root x is x in brackets. 2 times 1 is 2 root x. 2 times 1 is 2 root x. Do you see how these are exactly the same in the middle? When you multiply by 2 that are exactly the same, you get the same term twice in the middle. Instead of doubling it. And then 1 times 1 is 1. So I get 4x. 2 root x plus 2 root x is 4 root x's plus 1. Now we're actually going to move on to division. And in order to do division, you have to be able to multiply. Division is literally just multiplying. You'll see. So much. So we're going to flip over. Conjugates. Conjugates are two binomial factors whose product is the difference of two squares. To find the conjugate of a binomial, reverse the sign on the second term in the binomial, creating the difference of two squares. So if the binomial is 4 minus root x, its conjugate would be 4 plus root x. You just changed the middle sign. Okay? So when dividing radicals, this you did in grade 10. We're just remembering what we did in grade 10. Divide the coefficients and divide the radicands. So when we multiplied the coefficients and multiplied the radicands, right? Division is the exact same. Divide the coefficients, divide the radicands. Okay? Always rationalize the denominator when it contains the square root. So your denominators will never be allowed, the answer can never have a radical in the denominator. If it does, we have to rationalize it, which we're going to learn how to do today. And then the denominator contains the square root binomial, then find the conjugate of the denominator, multiply the numerator and denominator by the conjugate, simplify. Lovely, great information, but let's do some math with it first. So say we have square root 20 over square root 5. You were taught this in grade 10. Kate's like, no, I wasn't. Yes, you were. You were. So you were taught that if stop giving me the no, you weren't. I know you were. Okay. Just because it might have been online and you didn't watch the podcast does not mean you weren't taught it. It might mean that you chose not to learn it. Ah, there we are. We found out the real problem. Okay. So 20 and 5. If the two numbers can divide evenly with each other, you can write them as one big radical. That's what you're taught in grade 10. So if your two numbers can divide evenly into each other, you can write them under one big square root. And 20 and 5, I can, correct? So I can just write this as a big square root, and under it I can put 20 and 5. Now 20 divided by 5. Now I only ever write them together if they can go into each other evenly. Can they? Yes. If they can't, I don't write them together, okay? So what's 20 divided by 5? 4. So I get square root of 4, and what's the answer to the square root of 4? 2. Done. This is something you were taught in grade 10, whether you chose to listen to it or not, totally your choice. 90 and 15, do those divide evenly?
Yes.
Yes. Yeah, right?
Yeah.
Right.
Just got it.
Yeah. So 90 and 50 we can divide evenly. So we can go 90 divided by 15. How many times does 15 go into 90?
6.
6. So this we can write as the square root of 6. Can 6 simplify at all?
No.
Nope. Done. The only thing we're not allowed to do is have an answer with a denominator with a square root, correct? But our numerators can have square roots. Does this one have a denominator? Nope. So it's fine. We only have to keep going if our denominator has a square root. Okay, what about 45 and 5? X cubed and x7. Yes, 45 is divisible by 5. So we can write these together. So we can go 45 x cubed over 5 x7. I'm not going to do x7. I'm going to do x, make this be a 2 for now. Oh my goodness, that's a 2. Okay, what's 45 divided by 5? 9. And this x cubed and this x squared, 2 of these x's can cross off 2 of these, and I'm just left with an x on the top, correct? And my denominator's all gone. Can I reduce that at all?
Yes.
What can it break down into?
3.
The 9 can come out as a 3. So my answer would be 3 root x, and what do I have to do when I have a root x? X is greater than or equal to 0. You do the try. And then task 2, you're going to notice we can't do this. What are we going to have to do? Something different. So do the try. So we're going to get x over 4 technically on the outside. And on the inside, I'm going to get 18x cubed over 6x. This x crosses off one of these, so I'm left with an x squared on the top. And 18 divided by 6 is 3. So I'm going to get x over 4 root 3x squared. So the 4 could actually, this is over 1, isn't it? So the 4 could just go along the whole bottom. And the x squared can come out as a x and join the x. What's x times x? X squared root 3. And there was an x underneath actually, so I should have said x is greater than or equal to 0. What happens if I can't divide them? Well, I can. Like A, I could divide, but 15 divided by 2 is not even, which would make life worse. So, unless they divide evenly, do not do the division thing. Okay? But my problem here is that I have a radical in my denominator. Do you see that? That's never allowed. For A here, I have a root 2 in my denominator. That's never allowed. Now, if it's a monomial, it's really, really, really easy. Monomial meaning one term. So I have 5 root 2. There's no plus or minus signs in there, is it? What do I have to multiply root 2 by to get it to go away? To get the symbol to go away? Yeah. Root 2. Because root 2 times root 2 is 2, right? So if it's a monomial, which this is, there's no plus or minus signs, to rationalize my denominator, which means get the radical to go the heck away, I just multiplied by root 2, right? Because root 2 times root 2 is 2, correct? Can I just randomly multiply a denominator by something and have the same fraction? No. When I do the denominator, I have to do to the numerator. Could I have done this to the previous examples as well? Yes. These ones this special method for the first one, for task 1, you can only use if they divide evenly. But this method that I'm doing here, you could have used up here and it would still get you the same answer. Okay? So you multiply by the denominator radical. So let's see what we get. 8 root 15 times root 2 is what? 8 root 30. And then on the bottom, I get 5. Root 2 times root 2 is 5 times 2. So can I break down the 30? Any perfect squares going to 30? Trick question? Nope. So I'm going to get 8 root 30 over 10. Is there anything else I could do here? What? Simplify how? Divide each coefficient by 2. So this would become a 4, and this would become a 5. This is like the quadratic formula, right? If it had those coefficients, we could take it out. 3 for 1 deal. This is just a 2 for 1 deal. So I'm going to get 4 root 30 divided by 5. The try, what would I have to multiply by? Root 3. So what's root 10 times root 3? Square root 30 over what's root 3 times root 3? 3. Can I reduce the root 30? No. Is there a number in front of here that could cross off with the 3? No, I'm done. B, I have a root 75 in my denominator. How do I get rid of it? Multiply by root 75. So I'm going to get 25 root 75 over 75. Can I reduce the root 75? Yeah, into what? 25 and 3. Oh my gosh. The 25 comes out and it's a 5 over 75. So I'm going to get 25 times 5, which is 125 root 3 over 75. And try and what can I take out of both of these ones? 25, right? 125 divided by 5, or by 25, it's 5. 75 divided by 25 is 3. So my actual answer is 5 root 3 over 3. And the try, yep. Yes. So if you did the 75, simplified it, that's what you're saying? To 5 root 3 instead? And then just multiply by root 3? Totally. Yep. So he said, can I reduce this 75 to 5 root 3 first, and then just multiply by root 3? You absolutely can. So you can either reduce first, then multiply, or multiply, then reduce. And then this one I'm going to multiply by root 70. Oh my gosh, it keeps connecting my multiplication dots. Sure. Everything. That's 21 times root 70. A big number. What is the big number?
1,470.
1,470? Okay. Over 7 times 70. What does 1,470 break down into? Start typing.
490.
What?
That's not a perfect square, but
That's not helpful,
but
Katie.
it's the same as the 7 times 70.
735.
735.
Sorry there.
What? Divided by 49.
49 and 30. That's a much better. Oh, yeah, I like that one because it's a perfect square. So 49 times 30. The other ones were good answers. Not extremely helpful, but still correct. Yes. So I agree. Bring the 49 out, it becomes a 9. And by 9 I mean 7. That wasn't even right. Okay, 35 root 30 over 490. Should be able to take a 7 out of each of them. Oh, you got more. I can take 35. Take 35 out of them. 35 divided by 35 is 1. 490 divided by 35 is 14. So I get root 30 over 14.
20, I'm dividing 700.
Why do you have 700?
Yeah. 7 times 70 or
It's 490. It's not 700. I think you did 7 times 10. I'm 70 times 10? That's okay. I said that the square root of 49 is 9. So we're in the same boat. It's a scary boat to be in, but we're in the same boat. No. Okay. So so we're going to finish up radicals tomorrow, where we're going to do a monomial times a binomial top. We're also going to do when the bottom is a binomial as well, not just a monomial when it has two terms. Then all we have left to do is solving, and then we're done radicals. Oh, then we have a test. Your test is going to be Monday. Monday. Does next week make sense? Monday. Does next week's Monday does it make sense when I said we have dividing and solving left and we have a Friday?
November 1st.
No. If we do it, no, what are you doing? We're not doing it next Monday. We're doing it the following Monday. Next Monday doesn't make any sense. I wouldn't even be done all the curriculum. So the following Monday is when your test is going to be. Yeah, well, you know what?
One after Halloween, huh?
Oh.
Oh, come on. Do me like that. No, you can't do that.
Oh my goodness. Oh my goodness. You can't do, we all go, we're not even going to dress up, Mrs. Lepp. We're also not going to really take in Sunday, Halloween, but please don't do us like that. Okay, Paige. I might put it on the Thursday then, previously.
Oh. Which Thursday?
Next week.
Next week.
Yeah.
We won't be done.
Yeah, we would.
Okay, we can do it then. Just.
I said we wouldn't be done by Monday. This Monday.
Oh.
That's the following Thursday. That's like 4 more days.
We're close.
Come on, Kate.
Well, we still have time to do it.
We review all the time. People. Okay, number 6. ABC. Some good singing. And then 8AB. I know.